Hi and welcome to this video. It's the first of two videos on graph transformations. Hopefully you should have seen transformations at GCSE, and also hopefully, let's say your teacher will have given you a chance to get onto a piece of graphing software, for example Autograph or GeoBra or something like that, because the best way to understand these is to actually get in there, get on a piece of software and play around with them yourselves. So this video really is just going to review everything that you hopefully have discovered. Or if not, let's say it'll just take you through the basics of what's going on. So here we go. We've got different ways we can change a graph or transform a graph. We've got translations, stretches and reflections. And also in the second video we'll be having a look at function notation and what that looks like and how to interpret exam style questions. But this first video we're just going to be looking at the basic mechanisms of what's going on. So here we go. Right, so there's a task for you to begin with, so you might want to pause the video and just have a little go at that yourself, just by playing around with those equations and seeing what those do to the graphs. And if you've done all that, hopefully you should have found that for the first one, it's just basically shifted our basic y equals x squared curve has just been moved up 5 units, so we've got a vertical translation, or if we represent that as a vector, that's the vector 0, 5. For the second one, we can write that as y equals x minus 4 all squared. And let's say if you know what you're doing with intersectional ratio, we've got a repeated root at 4. It's going to go through the axis of 16, or you should discover that that is essentially just shifted our curve rightwards 4 units. So we've got a horizontal translation right 4 units. And again, watch out for that, because if you have a look at our bracketed version, yeah, it's moved in a positive direction, but the sign in the bracket is clearly a negative, so that's something we're going to have to think a little bit more about as we go through the video. And then the last one, the best way to go about this one is completed square, which is hopefully what you did to find where the minimum point is. And so we end up with y equals x plus 2 all squared minus 3, which gives us a minimum point at minus 2 minus 3. And you can find the roots by just putting y equals 0. You've got minus 2 plus or minus root 3 for your two roots. And essentially what's happened with that one is the curve has moved left 2 units and then down 3 units. And you can see that that's been reflected, you can see that in what it looks like in completed square version. And so what we've got is a translation by the vector minus 2, minus 3. Okay, so hopefully there's nothing particularly new or surprising in that. So let's just go and have a look at what's going to happen. So first of all, translations, as I said, Autograph or GeoBra would be a good place to go to play around with these things. And if we've done that, you should find that first of all, if you're just going to add a number outside our function, it's just going to cause the graph to move up or down. It's going to cause it to move vertically. It doesn't matter. In the last slide we had a quadratic. It doesn't matter what kind of function it is. If we're just adding something on the end, so there's our function. That one's a cubic. Y equals f of x, some cubic function for whatever it is, and just adding something on the end, in this case adding a, causes it to move up a units. If that was saying f of x minus a, it would have moved down a unit, so it's just a vertical shift. Doing the same thing, but this time putting it inside the function, so that was like from our previous slide, that x minus 4 all squared, so that's inside a squared function. What we've got, this one causes it to move horizontally, but this is what I mentioned before, it appears to be what our brain likes to think of as being the wrong way. We want a kind of a positive inside the bracket to move it to the right, and the negative to move to the left, but it actually moves it in the opposite direction. So what we've got here, there's our y equals f of x. If I do y equals f of x plus a, it's moving it left a unit. So all the points in that curve are just shifting to the left. Kind of like say our brains see that as being kind of the wrong way. Okay, so those were the shifts by adding, and find that by multiplying a function, what you get is stretches. By multiplying outside the function, you're getting a stretch, and in this case, multiplying by a gives you a stretch scale factor of a. So what happens effectively is we've got that. Notice that the points on the x-axis are unchanged, because if you take a coordinate that's 0 times by a, it's still at 0, so but everything that's just happening else is just stretching. So any point, for example, if a was 2, that point there, the distance from there to our axis has now been doubled to get from there to our axis. So the stretch is happening in the vertical direction for all the points in the curve. And by multiplying it inside the function, it's going to cause a horizontal stretch, but again, the horizontal ones are the weird ones. What actually happens is the scale factor is 1 over a. So for example, if I had y equals f of 2x, that would be a scale factor stretch of a half, 1 over 2. So what happens is essentially that. And hopefully you had a look at the easiest way to see those is actually when you start considering what happens with trig curves, if you've had a play around with those things. So those are our stretches, similar to the shifts where previously we were adding, and outside the function causes a vertical shift or a vertical stretch. Inside the function is a horizontal shift, horizontal stretch, and it's the horizontal ones, the ones that are doing slightly weird things. And the final thing to mention is that in this case it's the points that are on the y-axis that are the ones that are unchanged. Okay, and the final thing to think about are our reflections. This is where we've got negatives, and again you should have seen that a negative outside the function causes the curve to be reflected in the x-axis, so that's a vertical reflection essentially. So there's our function, and if we basically take each point of the curve, for example, if I take this point up here, whack a minus on the front of it, it's going to end up down here. Likewise, a point that's down here on my curve, put a minus on the front, it's going to end up here. So essentially the whole thing is being just reflected in the x-axis. And lastly, if we put a negative inside the function, it's going to cause the curve to be reflected in the y-axis, and so that's our horizontal reflection. And so what's essentially happening is that curve is now being reflected in the y-axis, which means it's swapping around that way around. And there's y equals f of minus x. So to summarize all of that, if we've got a function, then we've got adding it outside, it's a translation vertically, it goes up a units. Adding on the inside, it's a translation horizontally, minus a units, going the wrong way. The horizontal ones are the weird ones. For our stretches, there are multipliers, so outside is a stretch vertically, scale factor of a. And if we put that multiplier inside the function, it's a stretch horizontally, and the scale factor is 1 over a. Again, not quite as straightforward as you want it to be. And then finally, we've got our reflections. Outside reflects vertically, or is reflecting in the x-axis, and inside is causing the reflection in the y-axis. So if you're struggling to remember all of that, very essentially it is, if it's outside the function, the transformation is happening in the vertical direction. If it's inside the function, it's happening in the horizontal direction.